Okay, guys, a couple things first. Here is my working rubric for your project. Okay, after I met yesterday afternoon or yesterday at lunch with I think there were 4 of you guys in here, and then I met after school with Jared, and then before school this morning I had 2 people come in and talk also. This is what I have kind of a working form. Okay, I will hopefully have this done for you by tomorrow, and I will definitely have it up on my blog as soon as I get it finished. Okay, for now, like I said, this is not set in stone yet. I'm still making sure I have everything. But if you have your name, you get 5 points. If you don't have your name, it's 0 points. Okay. If you turn it in the pockets of a folder, you get 5 points. If it's stapled, 3 points. If it's together, 2 points. And if you didn't turn anything in, obviously you're going to get a 0. Okay. Color is 5 points. No color is 0 points. Okay. You got to have 5 parabolas. You got to have 5 vertical lines, 5 horizontal lines, 5 lines, 5 absolute value functions, 5 radical functions. Obviously for each one of those you get 2 points each. So however many you have, obviously it lines up, and if you didn't put any, it's a 0. You need to restrict either your domain or range on every function. I don't want just random lines going across the page. If you need it to go all the way across the page, you need to restrict the domain so that it's from the edge of the page to the other edge of the page. Or edge of the graph to the edge of the graph, yes? If you don't do that, you get 0 points out of 10. Okay? You turn it in on January the 24th, you get 15 points of extra credit. You turn it in January the 27th, it's 10, 28th is 7, 29th is 4, 30th is 1. It's due January 31st. Okay? Counting this weekend, that gives you 2 weekends if you're going to turn it in by the day that it's due. Okay, but if you want any extra points for turning it in early, obviously if you turn it in, you're still going to get 2 weekends even if you turn it in here. If you want those 5 extra points there, you'll need to turn it in before that second weekend. Okay, equation sheet, you either turn it in or you don't. It's either worth 15 points or 0 points. Okay, rational functions, logarithmic functions, and exponential functions are not requirements. Okay, they are extra. You will receive 2 points for each one that you include for a maximum of 5. Okay? So 5, if you do every single thing and every single thing right, 5, 10, 15, 30, 45, 55, 65, 75, 85, 95, 105, 115, 120, 125, 130. Okay? 130 is the maximum that you can have. So, are there any questions about this so far? Have any of you guys worked on this at all? You created an account? Good. Really? It wouldn't let you create an account on the phone? Okay. Okay. I know you can do it on the phone because Jared was working on his phone yesterday on it, so I know it can be done. It is not the easiest because it's small, okay? But it can be done on your phone. I really don't know if Jared had already created an account on the computer before he got on his phone to work. I really don't know, or if he just has one on his phone. I can't tell you that, and he can't either because he's not here. Okay? Oh, Kennedy. You can make circles. Okay, all you have to do is know the equations for circles. Okay, we don't get to that till Unit 12 or something like that at the very end of the year. Okay, look it up online. Circles are the easiest. You can make circles and you can make ovals, which in the real world are called ellipses. Actually, probably in the real world they're called ovals, but in the math world they're called ellipses. Okay, circles are really, really simple. X squared plus y squared equals a number squared. We call it r squared in a formula type thing. X squared plus y squared equals the radius squared. So whatever you want your radius of your circle to be, square it, and that's the number that needs to go here. And you can put it directly in to the line on the calculator that way, and get it done, get it taken care of. Okay. Mm-hmm. There's going to be a lot of experimentation. Even when I did it, there was a lot of experimentation. I mean, I put it in where I think it's supposed to be, and it's one off. Oh, I meant to put 15 and I accidentally put 16, so I had to go back and fix it. Something like that. You see what I'm saying? Or I put it in and decided I didn't want it there. Well, what do I have to do to make it go where I want it? That kind of thing. Okay? And what I hope you guys understand is that kind of thinking that has to go on is such higher level thinking about transformations. Okay? What do I have to do to make it move? That's what you're asking yourself. Okay? So that's why I'm so excited about this project. I think you're really going to like it once you get started into it. Okay? This one's not finished, and so let me get a chance to fix it. It should be up on my blog by this afternoon. Okay, and when I do get it up, I'll send you your Mind 101 with the link to it. Would that be okay for the rubric? Okay. The last thing I wanted to tell you is that yesterday I had a visitor third period. Okay, Mrs. Kinslow came to talk to me about a meeting that I missed on Friday when I was absent. Okay, she wanted to catch me up, and I wasn't in trouble. She was just catching me up on the stuff that I missed, and I still had my Misty with Penguin, that thing I showed you guys yesterday. I still had that shooting up on the screen. And she asked what it was, what it was about. And so I kind of explained the project to her, and she said, "Oh, who are you going to get to come and be the judges?" Well, I hadn't even thought about that at all. I figured I'd ask Miss Patton or Mr. Loper or something like that. And she said, "Oh, no, get somebody from outside. Get somebody from outside." She said in her experience that you guys make more of an effort if it's not just Miss Patton from across the hall. Not that there's anything wrong with Miss Patton from across the hall. She's amazing. Okay? And so in speaking with the students that came in this morning, I realized that if we do make it due January 31st, because as you can see, that's been what I've been kind of going back and forth on, when am I going to make it due. If I make it due January 31st, February 1st, the very next day, is the Big Country Math and Science Symposium, which is a whole big giant word for a bunch of math teachers and science teachers get together at the service center and do some workshops. Okay? I'm actually leading 3 different workshops that day, and possibly a 4th if there's room for it. Okay? And after this project, I may send an email to see if I can do one on this instead, or in addition to. Okay? If you guys seem to like it or something like that. Okay? But I'm going to be with a bunch of my math buddies that day. So I thought about emailing some of them and just saying, "Hey, can we meet at lunch? Can we sit together at lunch and have you guys go over these projects and choose a winner?" So it's always more fun when there's more than one winner. Okay? Because then more people are winners. Not that any of you guys are going to be losers, for the record. Okay? Unless you don't do the project, then you're a loser. Okay? Did I just say that out loud? Oh, great. And it's recorded. Excellent. The other thing that Mrs. Kinslow suggested that I thought was a great idea, and both of the sets of the students that I met with also thought it was a good idea, there's going to be 2 categories. Okay? There's not just one, make whatever you want. Okay? That is one of the categories, make whatever you want. It can have your name or not. Don't care. It can be whatever you want. That is school appropriate. Right? The second category, though, guys, is going to be a Clyde category, like for our city. Okay? And the things that are created that are purely whatever you want, those are the ones that the math teachers are going to judge. Okay? But the ones that are specifically focused on our city of Clyde, I'm not only going to have some math teachers judge those, but I'm also going to have some city people judge those. Okay, maybe the Chamber of Commerce lady. She's super nice. Okay, I don't think she would mind helping us out. Maybe our city secretary. She's super nice. Maybe one of our city councilmen. Okay, but the thing is July 4th, Clyde has a huge thing out at the lake, don't they? Okay, and so some sort of logo or some sort of picture advertising that out at the lake would be perfect, because they would have time to get it and use it if they wanted to, or just something like that. I'm not guaranteeing anybody that any logo that you guys would create would be used, but it would at least give the people at the city another option. Okay, and 99.9% of the time, this city supports our school better than any city that I've ever been a part of. Okay? And usually that 1% of the time it's because you guys can be jerks. Just teasing. Okay? So, but that would be something we could submit to the people that are coming to judge these or something like that they might be interested in using. Okay? So I kind of need to know ahead of time who's going to do a whatever you want kind of design and who's going to do a city design so that I can contact judges. Because if I'm not going to have any city designs, I don't need to contact any judges. But if I'm going to have only 2 or 3, guess what? You're probably going to be, we have a better chance of being a winner in a smaller group. You know what I'm saying? So if you, just in the next couple days, can let me know if you're going to do just a whatever you want kind of design or a city kind of design, I would appreciate that. Okay? Does that make sense? So 2 categories. Got it? I told you about the circle. Just look at the circle like I showed you was just y equals x squared equals y squared equals r squared. Did I say equals too many times? Sorry about that. And then you can look up the other, they're called conic sections, C-O-N-I-C, conic sections. If you want to look up equations for an ellipse, or actually a parabola is one of those. That's where we get this. That's where we study the sideways parabolas, the ones that are not functions. And there's also a one called a hyperbola, and it kind of looks like it has 2 parts. It doesn't, but we'll get into that later. But if you want those shapes, there's equations online for those. Did you notice that there is some automatically entered functions in there? There's like sine and cosine and tangent and things like that. There's a button you can get to on the screen on the calculator for those kind of functions. I don't know if you saw those or not, or if you even had a chance to play with it, but they are there. Okay. Anybody have any questions as far as the project goes? Can you enter both categories? I think probably just one, because otherwise you'd have to do 2 projects, and I don't know what I would do about that. If you can figure out a way, let me know. I'd love to hear it. Okay? Any other questions? You're good? Okay. So the first worksheet that I want to go through real quick is the squaring and rooting inverses worksheet. We didn't get a lot of chance yesterday to go over this, so I want to just talk with you just quickly about it. There's some things that I want you to make sure to have filled in. Did you have a chance to attempt any of these like I asked you to? Good. Okay, some of them, and that's what I asked, right? I asked for an attempt. Okay. I definitely want to turn to that second page. Okay, definitely want to turn to that second page. Does anybody have any questions about the front page, first of all, before I just go straight to the second page? Or are you good? Pretty straightforward? Okay. All right, so I want to go to the second page. Make sure that we have all of the blanks up here filled in. Okay, because this was kind of notes page. This page wasn't really something you guys could just automatically know the vocabulary and stuff like that. Not trying to offend you, because if I was, you would know. Okay, so these 2 relations are inverses of each other. Do you guys remember what the definition of an inverse is? It talked a little bit about it on the front page. Inverse, down here at the bottom. How do you find an inverse again? Obviously, we do need to talk about this a little bit. You switch the x and the y, okay? Does it say that anywhere, or did you remember that? Okay, x equals y squared if we're switching x and y. How do we solve this for y? You have x equals y squared, so to solve it, you take the square root of both sides, and you get y equals the square root of x, correct? Okay, so if you use a calculator and put that in the calculator, we do have a little bit of a problem, because what it looks like is that. Right? That's what it looks like? Oh yeah, function notation. You remember this kind of a notation? It's not really raised to the -1. This is the function notation. It's the inverse notation of function notation. That's how you know it's talking about an inverse with that -1 up there. So we just have the square root of x. Sorry, I skipped that just a moment ago. So does it make sense that the regular function would look like this, And then if we reflect it across the line y equals x, it would just look like this. What's the problem? It doesn't have a bottom, right? Okay, it doesn't have a bottom. So something's going on that we got to figure out. Okay, so on the next page, like I started off trying to show you with the notes, here's the graph. What's the equation for this graph? Y equals x squared. And what shape is it? A parabola. I need to add one word in there so that some of this is going to be a little more clear in just a moment. Okay? And that's going to be a vertical parabola. What do I mean by vertical? It's opening upward, right? Could a vertical parabola also open downward? Yes, but the main axis is a vertical line, right? Okay? So what about this one? What would it actually have to look like if it was an inverse? Here and here, right? If it was truly an inverse, it would have to look like that. What is this? What equation is this? X equals y squared. We talked a little bit about that yesterday when we were talking about our project, didn't we? Okay, what shape is it? Horizontal parabola, very good. So their graphs are blank over the line blank. Remember the properties of inverses? Can I change it and say reflections? Is that okay? Okay. R-E-F-L-E-C-T. They are reflections over the line. What are inverses? What line are inverses reflected over? Y equals x. So their equations. Now their graphs are reflected over the line y equals x. What's happening with their equations? What's switched in the equations? X and y. So here's the big deal. What's the problem with this graph? Very good. This graph is not a function. It's not just even regular. It's got an exclamation point there, right? It's not a function. That's a big deal for us because we've only dealt with functions so far this year, haven't we? In Algebra 1, did you ever deal with anything that was not a function? No. Okay? So normally we just graph the top half and call it the square root function. That's a weird way to say that, but it's kind of what's happening. Square root function. The square root function is really an inverse parabola. Absolutely. Okay? Any ideas? I may be skipping ahead of myself, and I probably am, but I don't care at this point. Do you have any idea how we would get the bottom half of the parabola? Negative. We would have to graph two different things in our calculator, right? Because our calculator won't graph it if it's not a function. So we'd have to have the square root of x, and then we'd have to graph the negative or the opposite of the square root of x. And then we could make this show up, couldn't we? Okay? Because remember, when we take the square root of a number, how many answers are we really getting? 2 answers, just like our conversation yesterday, correct? Okay. So here's our parent function. It gives us this information. Do you realize that it's switched of a parabola? 1 squared is 1, 2 squared is 4, 3 squared is 9. Or this time we can think of it the other way. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So graph that on this graph real quick, please. You got it? So that's the parent function, right? That's my parent function. So what's my domain of this parent function? Remind me what domain is again. The x values. So we think, how far left does this go and how far right does it go? It goes to 0. X is greater than or equal to 0. Very good. There were several of you who were saying things out loud and you were getting here. Okay? But good job. Very good job getting there. So you can only use the blank values for blank. How is another word we can another way we can say this in words? What does this mean? We can only use the positive. Very good. Values for x. What about range? Range is y values. Good. So we think how far down and how far up? Y is greater than or equal to 0. Very good. So in other words, we will only get positive values for y. Okay? Any questions so far? Now, so every square root function we're going to deal with has a domain of x is greater than or equal to 0 and a range of y is greater than or equal to 0. Which one has this as its domain and range? The parent, right? The parent function. Okay? So go ahead and continue or keep working on this page and the back page tonight. Okay? Go ahead and get that finished for tomorrow. And here's transformations. When we talk about transformations, we always talk about a transformed or changed function compared to what? The parent. Very good. The parent. Okay? So if this is the parent, guess what? We've already learned how to do this. We did it linear. We did it absolute value. We did it with quadratic. Now it's time for square root. All the same rules apply. It just visually looks different. So if we can get into our brain what's happening, we'll be fine. Okay? So it asks us to use our calculator. Mine has to come on. It gives us a specific window to use. So as soon as mine will come on, I'm going to open a graph. I'm probably not going to use my little scratch pad graph just because. Okay, so I'm going to have a new document. No, I don't want to save the old one. And I want this to be a graph. Okay. I want my window. How do I change my window? Menu. Window zoom. I want to change my window settings. And I want my x minimum to be negative 9.4. And my x maximum to be 9.4. I want to count by ones. My y min is negative 6.2. My y max is 6.2. And I want to count by ones. So my parent function is the square root of x. Did I expect it to look like that? Yes. Good. Okay. So this one, the next function that we want to talk about is this one in number 1. It is the square root of x plus 3. Notice that if I don't hit the right arrow after I write the square root of x, the plus 3 is going to be underneath the radical. Can you tell very clearly that this 3 is outside of the radical? Okay, so when I hit enter, what did it do? It moved up 3. Where is my end point? So here, up here it talked about the end point being at 0, 0. That's kind of the starting point of the square root function, right? If we're talking parabola-wise, that's my vertex, right? Okay, so where's my new end point? 0, 3. How does the function compare to the parent? So we can say translation 3 units up. That's great. Does anybody have another way they would rather say it? What kind of shift is it? Vertical shift up 3. But honestly, guys, for real, those two both mean the same things, and I've seen both of them show up on different tests, either SAT or ACT, something like that. Okay, I've seen both of them show up. So I really need you to know both of them. Okay, so on this one, we're going to put translated up 3 units. So can you make a prediction for me on number 2? Translation down 3 units? Well, let's check it out. I'm going to tab, and then I'm going to tab up because I already have most of this one in here. I'm just going to delete and put -3. Was it correct? Was our prediction correct? Move down 3. So for this one, just for a little variety, we're going to put a vertical shift. Down 3. Where's my new endpoint? 0, -3. Now, if I were checking your paper, I would get a little irritated at you. I just have to be honest. If this was your paper, because am I really taking the time to get the shape correct? No, and I should. I should take a little bit more time to get the shape correct. Okay? That's probably better. Do you see what I'm saying? Okay? And for the record, I wouldn't be mad. I would just help you fix it. Okay? So what's going to happen here? Prediction. You don't have to say it out loud, but at least make a prediction in your head. What's going to happen there? You think it's going to move left 3, even though it says +3? Because it's underneath. Because when we did quadratics, what happened when it was inside the parentheses of the squared term? It went opposite of what we thought, right? So is that going to be the same kind of thing here? Probably so. Let's check it out. So +3. Now, is it obvious to you that my +3 is inside my radical? Okay? Just be super careful of that. So was my prediction correct? Did it move left 3? So where's my new endpoint? -3, 0. How does it compare? So it translated left 3 units or horizontal shift left 3. Right? So what about number 4? One, two. You think it's going to be over there? Okay, let's go check it out. Guess what? Our prediction was correct. Okay? It moved 1 to the right 3. Our new endpoint is 3, 0. How did it compare? Horizontal shift right 3. Any questions? So what's going to change when there's 2 things happening? It's going to move left and up in this case, right? What's going to happen here? Right and down? Oh, what about 7? Skinnier. What do you mean by skinnier? Closer to the x-axis? It would be a compression or a stretch? I know, it's tricky, right? We try to think back to the parabola because we were pretty good at that, but this is the other way. So is it going to flatten it or is it going to make it wider? That's what you got to figure out. Okay? So you guys all have access to a calculator, right? Even if it's not one of these, guess what you can use? Decimals.com, your calculator, right? That online calculator, you can do all this stuff there as well. Okay, so I want the rest of this page finished. We do need to go real quick to the back. Okay, now I know that it seems like in order to summarize that we have to have done all the work first, but guess what? We've already done the work. Okay, we've already done the work. So let's go ahead and remember, see if we can remember the work we've done before. So if we're multiplying on the outside, like that 2.5 we were just looking at, if A is greater than 1, we're going to have a vertical stretch. Very, very good. If A is between 0 and 1, vertical compression. If A is less than 0, very good. You guys seem to remember this very well. Good. Keep it up. Okay? So what about a K, a number on the outside? If we're adding on the outside, adding K translates the graph up. Very good. Subtracting K translates or shifts the graph down. And last one, adding on the inside, adding H translates the graph which way? Left, very good. Subtracting H, where it shifts. Oh, don't forget your F's. Okay? Subtracting H shifts the graph to the right. So, A and B are different, okay? A and B right here are different, and these two on the back as well. So I'm going to do at least one of those with you before you go. Or before I let you go. Okay? Wait, how is it different? It's like opposite of the other ones, right? It doesn't give you the function rule, it just gives you the graph and asks for the function rule. The other one gave you the function rule and asked for the graph. So can you take the graph as it's given and find the function rule? Okay, prove it. Why do you think it's negative? So y equals negative what? Square root of x. Is there anything inside the radical with x? Did it shift left or right at all? Okay. Then what did it do? Added 5, so plus 5. Done. What about b? Good. Start with y equals. Wait, why 2? Where'd the 2 come from? How do you know it's 2? Just because Jacob said? So we automatically believe him? Good. Normally it goes over 1 up 1, over 4 up 2, right? This goes over 1 up 2, so you know you have to have a multiplier of 2, right? Okay? Very good, very good. So 2 is the multiplier. Oh, inside, so this needs to be longer, right? Plus 3. Always make it very clear. I know it took like a whole 0.73 seconds to draw the rest of this to make it longer. But always make it very clear if your 3 is inside or outside. At the very least, if you're having trouble making it clear, put some parentheses around it so you know for sure that that's all inside. I'm not going to require that of you if you make it a point to make it very clear. But if you're struggling, put it in parentheses so you know that you're clear that it's inside. That's all inside. Any questions? Okay, so you have 5 through 10 on this page, and then you have the back page, 1 through 4, and then 1 through 6. Okay? Any questions about that? Yeah, I want you to work on that too. Yeah.